Mm, let me share the screen. All right. Well, good morning, everyone. This is um, CNG 3351. We're going to start. This is the first lecture. It's actually introduction to transportation engineering system. My name is Mina Solomon. I have my PhD from Arizona State University back in 2012, and I got my PE a year and a half ago. I'm a registered professional engineer at the state of Texas. Yeah, the learning objectives for this lecture, we're gonna define what I mean by a transportation system, and then also we're gonna try to explain transportation engineering from three different areas of involvement. The first area is actually planning, designing, and engineering, such as operations and management. So, as a transportation engineer, you can be a planner, you can be a designer, and again, that depends on what involvement are you gonna end up with. Planning also has to do with anybody already knows what's the difference actually. So I hope you could now distinguish the difference between transportation engineering and traffic engineering. Transportation engineering is actually it's a wider net of a discipline that can cover traffic engineering as well as pavement engineering, which is the materials side of the roadway. So that's basically the difference. Also, one of the other learning objectives here is to introduce you to transportation-related organizations and professional societies. I know most of you might be familiar with ASCE, American Society of Civil Engineers, but also there is more societies that they are related to a certain discipline within civil engineering. And I'm going to introduce you to those as well. Last objective, we're going to explain what is a transportation engineer as a profession. If you end up being a transportation engineer, what does that really mean and what's your responsibilities as well as your privileges? And so let's start with the simple definition of the transportation system. Any transportation system is basically, again, it's a system that consists of a fixed facilities. And I'm going to here start to use my pen here. So it's the fixed facilities. So we have to have some fixed facilities. Well, and I'm going to explain what does that mean. The flow entities as well as the control system that actually will permit us as people as well as goods to overcome the friction of geographical space efficiently in order to participate in a timely manner in some desired activity. So, in other words, it's again, it's certain environment or certain facility. Facility can be a roadway is a facility, um, and again, the flow of entities. It's gonna again the flow of people as well as goods, and we need to control that system. Again, if we don't control it as an engineer, it's gonna just become a chaos. Controlling the system can be as simple as traffic signals. That's a control system, and it's going to permit people, of course, as well as goods to move and to move geographically, physically, from one place to the other in a very efficient way, and also in a timely manner. It's not, so efficiency here is again how easy it is to move from point A to point B, as well as on a timely manner. If you are attending a conference, for example, you need to be there at a certain time. That's why you're gonna maybe if it's out of state, you're gonna take a plane and you have to be there on time. If you are sending a Christmas gift, you want to make sure that there is a system that's gonna take this gift or receive it from point A. It's gonna be delivered to one of your loved ones on time, not after Christmas, for example. So this is what in a nutshell what the transportation system is all about. So what do I mean by fixed facilities? Fixed facilities, this is what transportation networks. It can so the facility, it's actually many components of the facility. And let me show it to you here also. It's transportation network. It can be either a physical or virtual, and it consists of a link, several links and nodes. So any transportation network, and a network here again, I can look at the city of our own here, and how are all the roadways that connected to each other. So there are links as well as nodes. The links, basically, it can be a roadway segment, again, a simple roadway, or it can be a railroad track. It can be a pipeline. It can be a flight, or even sending information through the internet using fiber optics. All of these are links. The nodes are actually, if I'm talking about a roadway, the node here in this case would be an intersection, or it can be a bus terminal, or it can be an airport, or it can be again a warehouse. If we're talking about pipelines, or we're talking about um, if we're talking about fiber optics, it's going to be maybe even a router. A router, that's a node. So that's basically what is a fixed facility is a fixed facility is all about, links as well as nodes. How about flow entities? Flow entities, it can be us as passengers, it can be vehicles, it can be containers, or as simple as data, moving data from point A to point B. That's also a certain flow entity that can move, and we are responsible to move from point A to point B. When it comes to passengers, there is a human factor. This is here now what's really very interesting about transportation engineers and transportation engineering compared to other subdisciplines in civil engineering. Civil engineering, we build homes, we build structures. All of those are actually stationary. If I'm building a house, I don't care who's gonna live in it. I may care about the weight, certain again the weight of the people, the weight of the furniture, but I really don't care how these human beings are gonna react. Or if I'm building a water reservoir, a dam, again I don't care about human factors here, except transportation. Transportation engineering is the only discipline that handle the human factor. You can build the best network ever, but if you're not taking the human factor into consideration, it's not going to work. We're dealing now with lots of, again, human beings, and every human being is unique, as you can tell, and we need to put that into consideration and in the back of our mind while we're designing roadways, while we're designing traffic signals, while we're designing horizontal alignments and vertical alignments. All of these are very critical in our discipline. Operators' physical and psychological activities is very important. And how are they dealing with interacting with fixed facilities during operation? Even how are vehicle drivers are dealing with each other. That's also very important. Travel behavior is another issue. Travel behavior, which is the reaction to traffic control devices. So, for example, we are going to end up talking about pavement marking. Pavement marking is a way to communicate between us as traffic engineers with the public. It's all about the visibility, again, visibility under different colors. We use different colors. We use white colors between adjacent lanes in the same direction. We use yellow colors in the opposite direction. We use different sizes of the markings. We use different shapes. And also, how can we deal with different weather conditions? All of these are, again, human factors and weather conditions that we have to consider while we're designing any transportation facility. Signal lights, whether again stop or run. Again, if you are getting closer and closer to an intersection, it's just turning yellow. We're going to talk about this in the next lecture, what we call the dilemma zone. Sometimes you reach an intersection, you are very confused whether to push hard on the gas and go and clear the intersection while it's almost orange or turning red, or push on the brake very hard and stop before you reach the stop line. All these are again something you need to keep in consideration. Radio, sometimes again, radio says congestion on I-20, mile post 10. Is that true or not? Will it still be congested by the time you get there? And that's why nowadays actually we even use Google Maps and Waze and other applications that can help us to predict as well as prepare ourselves for what's coming up for the next hour or two along the way. All of these again are has to do with flow entities. Also, besides passengers and human factors, vehicles and vehicle design, very important. Vehicles have been evolving quite drastically in the past 50 years. Um, Believe it or not, even as well as seat belts. Back in the 80s or early 90s, it was not even a law. It was not required. And we used to have lots of accidents related to that. Now it's a no-brainer. You have to have um, a belt. But how about the size? The size has been changing. The weight of the vehicles is different. How they accelerate and decelerate, and let alone the big elephant in the room is technology right there. Technology has been evolving, and now I thought we're not gonna see it, at least in my lifetime, is autonomous vehicles, self-driven vehicles. Very important, very interesting, and it's happening. Nowadays, the newer versions, at least we have one of the cool things is, for example, um, the how to maintain your speed. The cruise control is now very interesting. Cruise control now, this you don't have to if you're getting close to a vehicle, you don't have to push on the brakes to deactivate that. In fact, now you can set a speed and then you maintain that speed, let's say 70 miles per hour. And if you get closer, if your car gets closer to the car in front of it, it's gonna slow it down. And then once the distance is more more between the two vehicles, it's gonna speed up and get back to 70. So pretty much by the time you set the speed, you don't have to do much except just holding the steering wheel. And speaking of steering wheel, again, the newer versions and in the next couple of years, again, we're going to have a full autonomous cars. And how are we, transportation engineers, are ready to handle this on our network? Very big question marks. We're still thinking and working on it meanwhile. Any transportation system also it has to do with we also have to have a control system. So besides the fixed facility and the flow entities, we also have to control the system. Otherwise, again, things will be very chaotic. So first, we need to control the vehicle. The vehicle can be controlled. Again, this applies to individual vehicles. So far, again, still big chunk of our vehicles are controlled by us human beings. We have lots of computers in our cars, but still we have a good handle on how to control the vehicle. But soon enough, that's not going to be the case, and we need to have an idea what's gonna be happening and how we're gonna incorporate this in our new system. Some articles I've read recently, they were saying in the future, if it's autonomous vehicles, for example, we don't need to have traffic signals. Why? Because all the vehicles are going to be talking to each other, and therefore they will synchronize, and there's no need for a traffic signal. Every vehicle is going to know when is the time to when it's turn to move or to stop. There might even not even a need for enough sight distance. You're not going to be the one who's controlling it. Can I see for the next 200 feet or 500 feet, the vehicle sees that and we have sensors. That's also going to affect quite a bit the design of our roadways in the future. And many of these things you could think of speed limits. Do we need to have a speed limit or not? If there is certain curvatures that we tend to reduce the speed at those locations. Do we need to reduce that? Or the vehicle is going to sense that by itself and it's going to reduce the speed automatically. All these are question marks that we're gonna. You guys, again, this is good in terms of job security right there. Transportation engineering profession is not going anywhere. It's here and it's here to stay. Flow control is also very important. How can we control the flow, the stream of the vehicles, which applies actually to all the vehicles? There is, again, mechanism to guide the flow entities to efficiently and safely transfer the fixed facilities. This can be mandatory, some cases, and can be advisory. So mandatory, which is visible, this is has to do with traffic control devices, and we're going to get to learn that there are three levels of them. Between this class and 4351, we're going to get to know again what are the three levels. The first level is all the little intersections in our neighborhoods. There is no signal, not even stop sign or read sign. It's just the rules of the road, as we say. This is the first level. Second level, if we have from controlling a traffic and from controlling an intersection using a yield sign or a stop sign. And the third level, of course, is using traffic signals. Um, but also we can have an advisory, which is our hearable mechanism. So advisory, again, that's traffic information through the radio or dynamic messaging signs. Sometimes I don't know how many of you are still using radio, but definitely we're using Google Maps, Waze, and other applications, as well as now you're seeing those sign dynamic messages that it can tell you what's going on. If there's an accident, 15, 20 minutes, and the DOT will have the capability to update that sign to tell you what's going on. It can tell you that the off-road closures and any other information that we need to deliver to the public. Another thing also that we're dealing with when it comes to controlling the system is intelligent transportation systems, ITS. Intelligent transportation system basically is utilize multiple technologies as well as hardwares and softwares to improve the efficiency as well as safety of the transportation system by actually improving the control system. We can some of those systems including taking into account again man-machine interactions. We can have, if you typically used to go to Dallas Fort Worth, for example, you don't have to, if you have the tag, you don't have to stop. You can go through the terminal or go through the gates of the airport very easily because it reads. Um, Sometimes even there is multiple ITS, which were technologies that we're going to cover in the next few slides. Okay, so now remember we're still defining what's the transportation system. So far we've talked uh, we've talked about we've talked about fixed facilities, we've talked about flow entities, we've talked about control system. So now after we defined all these, now we're going to talk about the desired activity. Why do we use the transportation system? There's so many activities that we use transportation systems to achieve. So transportation again involves movements, as we said, movements of people, us, as well as goods. So basically, we are really changing in space as well as time. We are moving. If I'm going from here to Dallas, again, I'm moving in space as well as I'm moving in time. Either and, yeah. So it's or time between time and space and utility. Utility here, what do I mean by utility is actually is a measure of satisfaction or usefulness um, of that system. So transportation is therefore, as I mentioned here, generally again, it's not an end as itself. It actually occurs to satisfy the demand for some other activities at the destination. So, for example, if you're driving from your home to from your home to university, it's not your desire just to drive for the sake of driving. Driving here or transportation or you're going to use the transportation system is actually it's a utility. It's a mean to get you from to your destination. From where are you now to your destination? Going to school, going to work, going shopping, recreation, visiting with friends. All of these are your destination. But meanwhile, you will be using a transportation system to go and see and achieve those activities. And that's why again, transportation is a derived demand. It's not really a pure demand where I just want to drive for the sake of driving. It's actually a derived demand because I need to achieve other goals and that's why I'm going to end up using those transportation systems. But also, it's not just about moving people and goods from point A to point B. You also need to move them efficiently. That's very important. Efficiency here is all about safety and how quick it is. Those are very important two factors. Safety, of course, is number one all the time when it comes to transportation engineering. But also, you would like to get people as well as goods from point A to point B in a very quick manner. Again, talking about quick, again, there are two dimensions here about efficiency. Again, it's time and space. You need to get them timely. Again, you can't be too late if you are going to a job interview. You have to trust the system. You have to trust the transportation system, and you need to plan ahead of time. And if you get in your car and it's telling you it's going to take you an hour and a half to get to Dallas to go to an interview, you need to make sure that you need to trust the system that you're going to be there at 1.5 hours or maybe plus or minus 5 or 10 minutes. You can't have an expectation to drive 1.5 hours and it takes you 3 hours. That is not an efficient system as well as it's not a trusted system. You also have to overcome meanwhile going from here to Tyler. And I'm going to pick this example by the way a lot. Driving from Tyler to Dallas. You're going to overcome geographical space basically are gonna go across the bridge. Sometimes if you are going overseas, you're gonna even across continents, oceans, and eventually spaces. All right. So in a nutshell, again, transportation engineering, then it's the application of technological and scientific principles to the planning, functional design, operation, as well as management of facilities for any mode of transportation. So if you end up being a transportation engineer, you can specialize in one of these three involvements. You can be a planner. You can plan, for example, what does that mean? There's lots of cities, for example, is even opening up or expanding. Maybe not here in Thailand more than Dallas Fort Worth. Every time I go there and visit my in-laws, there's little cities opening up in North Dallas Fort Worth. So there is lots of demand for transportation engineers to plan those cities. You have to plan the traffic network. You have to plan new roadways. You have to plan what's going to be the demand here or there, depending on the zoning, to provide for this demand. You have to plan. Also, you can end up being a designer. You can design a roadway. You can design traffic signals. You can design the thickness of the layers of the pavement that you're going to be driving on. Or you can end up being in operation and management. That means you plan things are planned already and it's already designed. Now the system is there. As a traffic engineer, now you need to operate it and manage it as well as maintaining it with time. And we're going to try to cover each one of those concepts depending on the chapter. So planning, we're going to have it in chapter 7 and 8. Design is going to be chapter 2. And operation and management mainly is from chapter 3 to chapter 6. Transportation engineering, first planning. I think I've gone already through this, but let me give you a little bit more information about what do I mean by each one of those involvements. Planning aspects of transportation engineering relate to urban planning and involve technical forecasting decisions and more difficult political factors. Again, planning is never an easy job, and sometimes engineering and political factors they hopefully they are parallel to each other, not conflicting with each other. Technical forecasting or urban passenger travel presently involves what is called again four-step urban transportation planning. What are those four steps to plan in the right way? It's all about trip generation, which is you need to plan how many trips for what purpose. Also, you need to involve trip distribution, which is now we need to know what's the destination choice. Where are you basically where are people are expected to go at this location? And then you need to think of the mode choice. What mode choice are you using? Are you using your own vehicle, public or public transportation? And then the fourth step is traffic assignment, which is basically which street are people are going to be using, what transit routes are going to be used, and so on and so forth. That's basically planning. Travel demand forecasting. This is here a little bit of history. In 1962, the Federal Highway Act was initiated, and it actually is a good one because it required that all cities with a population of more than 50,000 people, they must have a comprehensive long-term transportation plan, and they must be connected to the interstate system. That's why, for example, our city of Tyler here, at nighttime we're 100,000 people. In the morning, we're reaching 250,000 people because people are coming from all the little cities around us to work or study. So that's why we have I-20 just on the north of the city. You may wonder why we do not have it in the middle of the city. Could have saved some time, similar to what we have, for example, in Dallas Fort Worth. But I've heard lots of stories that the forefathers of the city they did not want the interstate to go through the downtown, and that not to bring noise and too much um, involvements. So they decided to put it north. But now we're trying to fix it by having another loop, which is the bigger loop, the loop 49, to get us connected in a quicker way to the interstate I-20. And of course, every single city that's more than 50,000 people, they're supposed to have an MPO, which is Metropolitan Planning Organization. You need to, by the way, one of the things here sometimes I hit on in the exams are acronyms. We use them a lot, and typically I would like for you to know what are these acronyms. Sometimes you can hear about them in exams or interviews. So MPO is a Metropolitan Planning Organization. Please go ahead to the City of Tyler website and you can hear more and you can read more about it on the website. Again, part of planning is forecasting, and forecasting is not an easy task, as you may expect. Now, here I have a couple quotes from two different people. John Kenneth Galbraith, he said, we have two classes of forecasters. This is quite ironic. Two classes of forecasters, those who do not know and those who do not know that they don't know. So that's actually very true. So you would hope that forecasters, they know a little bit more, but it's not an easy job. Also, Alan Kirsten and from Motorola, he was saying, and I think we're seeing this already now, but we're getting close. But trucks of the future will only have a man, a dog, and a computer on the board. The computer will be there to control the truck. The man will be there to watch the gauges, and the dog will be there to bite the man if he attempts to touch anything. So with time, I think we're gonna be, I don't know, we might really see this in the near future, where if we don't want to mess up with the vehicle anymore, and it's gonna be 100% self-driven. But time will tell. The other aspect, if you don't like to be a planner, you can be a designer. So traffic engineering or transportation engineering in general, it has many design aspects that includes the sizing of transportation facilities, which means how many lanes do I have to have in this roadway, how much capacity of this facility it can handle. It also under design, it can also determine the materials and the thickness used in the pavement. So pavement if you're wondering, we derive one roadway that's designed of multiple layers. The top layer, we call it HMA, which is hot mix asphalt. And then underneath that, we have a base layer, which is crushed aggregate. HMA is basically asphalt as well as aggregates. So asphalt, that's the one of the byproducts of petroleum refinery. This is the bottom of it. We take it, heat it, mix it with aggregates, crushed rocks basically, and we pave the roadways with it. And then we have a base, which is just aggregates, crushed aggregates. And then we can have a sub base. And then all of this will be on top of the soil, or there's a fancy word for the soil is subgrade. Subgrade. So you can end up being a pavement engineer. In fact, that's my research expertise is pavement engineering. Or you can end up designing the geometry of the roadway. So vertical and horizontal alignment. We're going to spend quite a bit of time in the next few weeks to talk about vertical and horizontal alignment. For example, horizontal alignment, if you take a look at the roadway from the plane view, um, roadways are not always straight. So those curvatures here, they're going to have certain radii. We're going to design those. Also vertical alignment, sometimes going again, if you take a look at the profile of the roadway, and if this is here your vehicle trying to climb this roadway, and then it's going down, going up, again, those ups and downs, there's also radius design for each one of those curvatures, and that's vertical alignments. We're gonna talk about this, but again, this can be your profession as a geometric designer. Road design, again, it includes, as I mentioned, geometric design. You can design highway engineering, the grades. Again, how steep is the roadway? This is what I mean by the grade. The surface texture. Again, is it you don't want to have it, the texture to be too smooth or too rough. If it's too smooth, it's gonna be hard to control the vehicle, especially in an icy conditions. You don't have it very rough because now it's gonna ruin your vehicle. It's gonna consume more fuel with time. You also can design the sight distance. Again, how much in advance you need to see in front of you to avoid any danger that you can see, and you can hit on the brake on a timely manner, and you can reach a full stop before you hit that danger in front of you. You also can design horizontal bends and vertical slopes, as well as design speed, which we're going to discuss in more details in CNG 4351, as well as again structural road design. And another fun part, which many of you may not think this is part of civil engineering, we are the ones who design airports. We do design runways, we do design taxiways, we do design the thickness of each of the layers of the taxiways and the runways. So it's again, it's very interesting fact. But yeah, we are civil engineers, mainly transportation engineers. We design airports. Yeah, as a structural engineer, we ensure that the road is strong enough for the expected number of vehicles for a certain number of years. The last profession or the last sub-profession under transportation engineering, you can be in operation and management. So operations and management involve traffic engineering so that the vehicles move smoothly on any roadway or any track. All the techniques of managing roadways as well as operating it in a right manner, using signs, signals, as well as marking. Nowadays, there is even newer techniques such as the Intelligent Transportation System, the ITS, which include again advanced travel information, such as again variable messages signs. We can also have advanced traffic control system, such as ramp meters. We can have managed lanes. We can have roadway pricing. We can have HOV lanes that they can be HOV lanes for certain times of the day, and they can turn out to be regular lanes in another time of the day. All of these again are certain ways to operate and manage the transportation system. What is being done? The role of engineers in transportation engineering. Again, those are as I was. This is just a summary. We can have planners, we can have designers, we can have people to operate, and those are the professions involved. If you're thinking you're just gonna deal with civil engineers all your career, you are mistaken. As transportation engineer in planning, you're gonna end up working with other civil engineers, economists, financial analysis, social scientists, and others, even environmental science. As a designer, you are going to deal with structural engineers, construction management managers, geotechnical, hydraulics, mechanical engineers, electrical engineers, and management, as well as architects. And for operations, you are going to be dealing with lots of business administrators, transportation and traffic engineers, as well as IOR, as well as economists. Very interesting and rewarding career, actually. How are we organized? We are organized as traffic engineers, as the majority of their decisions on consumption and provisions of transportation in the US is made by individuals and private concerns. In fact, the principal private providers of transportations are, of course, the trucking companies, railroads, airlines, pipeline companies, shipping companies, vehicle manufacturers. All of these um, are the providers. Among the key public agencies, again, I'm mentioning here examples. Again, we have, of course, state and local public utilities commissioners. You can have the Federal Interstate Commerce Commission, all the way to the Metropolitan Planning Organization that I just mentioned, to the MPO. Every city that's more than 50,000 people, they have to have an MPO. These are here the U.S. Department of Transportation. This is the big umbrella underneath. There is everything has to do with transportation. So the U.S. DOT was formed in 1967. It has gone through lots of several changes and its organizational structure. And now there is multiple administrations under the U.S. DOT. One of the famous ones is the FAA, the Federal Aviation Administration, and of course the major one that affects our roadways are the Federal Highway Administration, FHWA. Those are the two, one of the two major ones that we're gonna discuss in this class as well. Other federal agencies that has anything to do with transportation related roles are the Department of Homeland Security, the U.S. Forest Service, the National Park Service, as well as the Indian Affairs. Some of the national professional societies that I highly recommend you to join. I'll jump to the bottom of the list. You guys are familiar with ASC, or I hope you are, and I highly recommend you to join as a student in the student chapter. It's free, but also me and Dr. Vishon, another transportation engineer in our department, we are having the ITE, Institute of Transportation Engineers. We just started the student chapter. I highly recommend you, if you are interested in transportation engineering as your future profession, to reach out to me. How can you be a member? It's free. So please have that in mind. Another one of my favorites, which is actually happening as I'm talking to you because of COVID. I'm not traveling to Washington, D.C. this year. Is TRB, Transportation Research Board. It has an annual meeting. It's a big conference actually every year. About 15,000 people gather in Washington, D.C. from across the globe every year, the second week of January, to discuss the up-to-date research outcomes that has to do with transportation. Anything that you could think of has to do with transportation. This is this year is the 100th annual meeting, and unfortunately, as you may expect, again, it's virtual because of what we're going through right now. But it's a fun and interesting meeting that I've been going to Washington D.C. I visited the city about 12 times in the past 13 years for the sake of attending this important conference. Another very important association, sometimes I talk about this in exam or ask you, what does AASHTO mean? AASHTO is the American Association of State Highway and Transportation Officials. Very important. This is one of the big entities that handles publication of current practices, design standards, as well as rehabilitation manuals. I highly recommend you, if you have a couple minutes, to take a look at ashto.org and take a look at the website. There's also other state and regional and county, as well as city level organizations. So please go to Texas Department of Transportation. This is what I mean by TxDOT. I can ask also about this in the exam. It's one of the biggest DOTs in the nation. It handles thousands of miles. So many of our previous students, they end up working for TxDOT, and that can be your future career. Very rewarding career at TxDOT as well. We can also have regional, county, and city level organizations. Again, we can have the NPO, as well as Department of Public Works, Department of Highway and Transportation, Department of Planning, Department of Traffic Engineering. How about jobs now? Everyone is talking about how can I get a job. Is transportation engineering is the right field for me? Opportunities for civil engineering and transportation is limitless. There is a lot of specialties. We got to know that you can be again a planner, a designer, or construction, or operation, or maintenance. An engineer must consider, if you end up being a transportation engineer, you have to consider first of all is safety. Safety again very important. Public welfare as well as the environment. Second is will be economy. Again, you need to have that in mind that you are entrusted with taxpayers' money. How are you going to use it efficiently? But again, safety is always number one. Here are some examples. But of course, the last thing is quality of life, quality of service, very important. So I can ask you this in an exam. Give me again the three considerations as an engineer. It's all about again safety, economy, and then quality of service. Of course, you have to. Fourth is the risk. Everything has a certain risk, and your goal again to reduce that risk on the public. This is just a big table. I'm not going to go through the details here, but just giving you what's the specialties under transportation engineering. What are the tasks that you are expected to do if you end up selecting certain specialty, and what are the needed training that you need to have. Most of the time, transportation engineers, they end up, 40% of them, they're going to end up working under the government. Government, it can be again the DOT or the city or the Federal Highway Administration, 40%, 50% as consultants, and 5% as in research and teaching, like myself. I That's my passion to teach and transfer the knowledge that I had to the new generation as well as the other 5% in trucking and rail firms. There's lots of pay and perks to this profession. I think these numbers, I think 45 now is an outdated number. Most of our students who end up being in transportation, they start with 60K, believe it or not. And it can be, I've seen students nowadays with 5 years of experience. Yes, they are reaching the number that you're seeing on the screen. So it's a very rewarding career, um, except for if you're teaching. Again, we get paid 9 months um, out of 12 months because we don't teach. If we don't teach in the summer, that again, it's not the best pay being a professor, but it's all about the passion and money is not everything, and that's why uh, I like to do what I like to do is again doing research and teaching. But I've seen many of my students that they graduated a couple of years after graduation. They are having a salary as twice as their professor, which is make us feel good. Trust me. Produce again tangible changes. That's also a nice thing. You are gonna get to see. You're gonna have a good source of satisfaction when you do something that you get to be installed in your city. For example, a couple of years ago, I was involved with if you heard about it, the bike lane project for the city of Thailand. I was the one who designed it, planned it, and then delivered it to the city. And now the city is soliciting for contractors to do it. Once it's done, you have a bike lane or something similar. You're gonna have that feel of satisfaction that you did something good for your own city. The transportation workforce, again, in the United States is facing concerning shortage. 50% of the state transportation workforce will be eligible to retire in the next 10 years. So again, job security, we need lots of transportation engineers. And the good news is CNN lists civil engineering profession as the 30th best job in America. So I think that's something good also to keep in mind. With that, I think I would like to stop at this point here for chapter one, and we will discuss the next part of the chapter and the next meeting. All right, I think recording has stopped. If I'm not, oh, well.